Hello friends, in CurveTracing, there is another point called as which helps us in tracing any curve, and that is the tangents. So nature of tangents to the curve is very important to determine. So how you determine the nature of tangents for a given curve without drawing the curve? Okay, so whatever the given equation for us, there is a very simple rule called as Newton's method. So Newton's method says that you take the lowest degree term in the equation and equate it to 0. Okay, this equation will give you the equation of the tangent to the curve. Okay, it's a very simple method. So the lowest degree term, please remember this. The lowest degree term in the equation, you equate it to 0. Okay, and that will give you the equation of the tangent. This is called as Newton method. Okay, we'll see the illustration of this. Fine. So now let me take some of the curves over here. Let me take y is equal to x square. So here first of all I am taking known curves so that you can easily determine. Now in this equation, what is the lowest degree term? Okay, lowest degree term is of course y. So if I equate y equal to 0, so this is lowest degree term. Y equal to 0, right? Y is the lowest degree term, equate it to 0. What is this equation? This equation is the equation of x-axis, right? So to this curve, x-axis is the tangent. Okay, remember this Newton method is applied only when you are determining the tangents at origin. Okay, so to this curve at origin, y equal to 0, that is x-axis is the tangent. If you draw this curve, it is like this. This is y equal to x square. See that this x-axis becomes the tangent at origin. Okay, another example you can take, y square is equal to x. Okay, lowest degree term is what? X. So x equal to 0, if you take, this is y-axis, and this becomes the tangent at origin to this curve. Okay, tangent at origin. Remember, this Newton method that we are working with just now, okay, this is applicable to find out the tangents to the curve at origin only. Okay, not at any other arbitrary point. So fine, so what is this? This curve like this one. Okay, y square equal to x. See, this is the tangent at origin. Okay, so this is the tangent. Fine. Okay. Now let us take another example. uh, Let me take the example of, say, y equal to x cube. First we will determine whether this curve passes through origin, then we can only determine the tangent at origin, right? Okay, so since origin 0 comma 0 satisfies this equation, therefore this curve definitely passes through origin. Now the lowest degree term is y. So if I equate y equal to 0, that means what? The x-axis will be the tangent to this curve at origin. So let me draw this curve. Y equal to x cube is like this. Okay, this is y equal to x cube. See what is the tangent to this curve at origin. It is y equal to 0. That means this is the tangent. This is the tangent. Understood? So Newton's rule says that, okay, so let me write down that once again here. If y equal to f of x is passing through origin, equate lowest degree term to 0, equate lowest degree term to 0 to get the tangent to the curve. Okay, so if your y equal to fx is passing through the origin, okay, you equate the lowest degree term of the equation, okay, and that gives you directly the equation of the tangent. So it's a very simple method to get the tangent to the curve at origin. Okay. Now sometimes the curve may not pass through origin. Okay, so at any arbitrary point, how you get the tangent? So that is a very interesting point. Here we are not looking at exactly the tangent, but we are looking at the nature of the tangent, right? So see that if y equal to fx, okay, is a given curve, is a given equation, okay, and p be any arbitrary point on the equation. P is any point on curve. Okay, so how will find out the tangent at this point P, and what is the nature of the tangent basically? So we will find out dy by dx. Okay, and at this point P, so we'll obtain the slope of the tangent, and that gives me the nature. Fine. Okay, if this slope is equal to 0, what do you say? Certainly the tangent has to be parallel to x-axis. Okay, if this is equal to infinity, what do you say? The tangent has to be parallel to y-axis. Okay, and if it is positive, the tangents are oblique like this, so the tangents will be like this. If it is positive, all tangents of positive slope. If it is negative, the opposite of that, negative slope, and so on. So we can determine the nature of the tangent by looking at the derivative at that point. Okay, because this gives me the slope, right? These two slopes are very important for us, parallel to x-axis, parallel to y-axis, right? So please note all these things. We will see the illustrations in the next video.